Alright, we've got a 1 centimeter tall object. It's going to be 1 centimeter in front of a converging lens with a focal length of 2 centimeters. So that you don't run out of space. Alright, so here's our setup. We've got the focal points 2 centimeters away from the lens. Okay. And our object distance is rather small here. Okay, that's SO. Alright, now we want to use the same construction principles that we used before. One ray can leave the tip of the object going parallel to the ground, and that ray is going to bend through the focal point. Another ray can leave the tip of the object and go through the center of the lens. That ray, though, will not be deflected. It'll just pass straight through. Now, as you can see, these rays do not intersect on the right side of the lens. So we have to think of alternative ways to get them to intersect somewhere, hopefully. Sometimes the rays will just never intersect and then no image will be formed. But in this case, they will intersect as long as we trace them back in space. There we go. Alright, so they converge at a point which is in front of the lens, though. Because we call that the front, this is the back. So what do? Well, we construct the image. But this time, the image is drawn with dashes. Why is that? Well, instead of making it solid, we draw it dashed by convention or kind of grayed out, because this is what's called a virtual image. And the reasoning why it's called virtual is because the light beams that leave that object do not actually pass through the point that I've constructed. Instead, they just appear to the eye, like if you're over here looking, then you would think that the rays are coming from that point. That's how it would appear to you, but they're not really coming from that point. It just appears that way. I'm going to quickly find the answers to this with the formulas. Okay, so there's the thin lens formula. Now, let's see, we'll plug in our object distance of 1 centimeter. We want to find the image distance. Use a focal length of 2 centimeters. Therefore, SI is -2 centimeters. The negative indicates that it is going to be in front of the lens. Remember before we had gotten positive. We had gotten positive image distance is. Now we're getting a negative, which means it's on the opposite side that those other images were on. Okay, now let's find the magnification. Alright, that's going to be, don't forget the double negative there. It looks like our magnification is going to be 2. I had to put in an image distance that was negative, but there's also a negative in the formula. So our magnification is 2. That means that our final image is going to be upright. Okay, and then the last formula, HI equals MHO, 2 times 1, 2 centimeters for the height of the image.